All right, in this video, we're going to talk about section 6.5, volume. Let's look at our objectives really quick. We're going to use volume formulas to compute the volumes of three-dimensional figures. We're going to solve some applied problems. We're also going to look at some surface area formulas of three-dimensional objects. Okay, so let's jump in. So formulas for volume. Volume of a rectangular solid, so it has 90-degree angles at the corners. The volume of a rectangular solid is length times width times height. And you can see these lovely pictures here where they show us a cubic unit. So that would mean this is 1 unit on each, the length, the width, and the height. So 1 unit of length on each of those edges. So it's 1 cubic unit, 1 by 1 by 1. And if I have a 3 by 3 by 2, then I could fit 3 times 3, which is 9. Notice there are 9 in this bottom layer, and then there will be 9 in each of in the top layer as well. So you can see them 1, 2, 3, 4, 5, 6, 7, 8, 9 on the top layer, 9 on the bottom layer. So I have 3 times 3 times 2, or 18 that fit in there. So it kind of makes sense if you think about it. Not kind of, it does. So the formulas for box-like shapes. If it's a rectangular solid, the volume is length times width times height. So rectangular just means I have right angles on the corners or at the corners. And if it's a cube, that means all 3 sides are the same length. So we get length times width times height being s times s times s, or s to the 3rd power. Okay, so we're going to look at a little swimming pool example. So let's take our little swimming pool. We're going to dig in our backyard. The first step is to have a hole dug. My neighbors did this a while back. It's 90 feet long that we're going to dig this hole, 60 feet wide and 6 feet deep. You'll use a truck that can carry 10 cubic yards of dirt, but it charges $35 per load. How much will it cost you to have all the dirt hauled away? Now notice this is cubic yards, and our dimensions were measured in feet. So we're going to change all of these feet to yards so that we can figure out how many cubic yards of dirt need to be hauled away. Okay, so we'll convert the length. It's going to be 90 divided by 3, or 30 yards. We're going to convert the width from 60 feet. We'll divide by 3 to get 20 yards. And the depth, or the height of our pool, 6 divided by 3, which is 2 yards. Then if we multiply those 3 dimensions together, length times width times height, we will have the volume of dirt that needs to be hauled away. So we do 30. Here they've done the calculation for us. Basically, 30 times 20 times 2. And we'll grab our calculator and do that. 30 times 20 times 2. 1,200 cubic yards. Now, if the truck charges $35 for every 10 cubic yards, I need to figure out how many truckloads are going to have to be hauled away. It's going to be 1,200 divided by 10. That's a lot of truckloads. It's 120 truckloads. That's a lot. So 120 truckloads, and at $35 per truckload, so we'll do 120 times 35. And it will tell us that we owe our person $4,200 to haul off that dirt. All right, so we'll fill in the blank here. It would cost $4,200 to have our dirt hauled away. Okay. Next thing that we're going to look at is the volume of a pyramid. So a pyramid can have a different shape for the base. This one happens to have looks like a rectangle at the base. So the volume of a pyramid, it's 1/3 times the area of the base times the height. Notice the height is measured from that top point perpendicular to the base. Okay, distance from the top to the base, perpendicular distance. Okay, when we talk about distance between two things, it's perpendicular distance. So 1/3 times the area of the base times the height. That's the volume. So let's do an example. So use the formula for pyramid's volume to find the volume of the pyramid described. So capped with a pointed spire on top of its 48 stories, the Transamerica Tower in San Francisco is a pyramid with a square base. Notice that's square base. I want to underline that word, square. Okay, it's got a square base. The pyramid is 256 meters tall. So the height of our pyramid, 256 meters, which they tell us is 853 feet tall. Okay. Each side of the square base has a length of 52 meters. So my length and my width are the same. In other words, it's a square base. We could just do it this way. San Franciscans didn't like it, but now they accept it. Okay, cool. Area of the square base is 52 squared. It's a square base, so 52 times 52 are 52 squared. Length and the width are the same. So 52 times 52, which is, and this is going to be meters squared because these are in meters. Meters times meters will be meters squared. Let's do that calculation. 2,704 square meters. The volume of the pyramid then is going to be 1/3 times 2,704 times the height, which we said was 256 meters. So let's do that calculation. 2,704 times 256. And then I'm going to divide that by 3, because that's really what this is, right? Multiplying by 1/3 is the same as dividing by 3. So I can do this multiplication and then divide my answer there by 3. So I'm going to round it to the nearest whole meter, and that would be 230,000. Oops. No, 230,000. 230,741 meters cubed. Volume is always in cubic units. Okay, off we go. Volume of a right circular cylinder. What is a right circular cylinder? Oh, it's like a soup can. Look. Yes. So the base and the top are both circles, and every cross section is a circle. Every one of these little cross sections is a circle. Right? Right circular cylinder, often just called a cylinder. Okay, so the volume of a right circular cylinder is pi r squared times h. So the area of the base is pi r squared, and then we just multiply by the height. Area of the base times the height. Pi r squared h. That's a formula we might want to take note of. And the height, notice, is measured perpendicular to the radius there. So the volume of a right circular cylinder, let's do this example. So they gave us the diameter. I need the radius. The radius is going to be 10. Okay? So our radius is 10. Chop that 20 in half. So our volume is going to be pi r squared times h. 100, that's 10 squared is 100. 100 times 9 is 900, so we get 900 pi cubic yards, right? Or if we needed that multiplied out, we would grab our calculator and we would do 900 times pi, and we get 2,827.43. Or if we rounded it to the nearest whole cubic yard, 2,827. I think we'll go 2,827.43 cubic yards. Yards cubed or cubic yards, right? Cubic yards. All right, next example. Volume of a cone and a sphere. So let's do these formulas. The volume V of a right circular cone. So this is a right circular cone. They've shown us a picture of one right over here. Notice that the base is a circle, hence the circular. Right, because the tip of the cone is directly above the center of that circular base. All right, so the height is h, the radius is r, and the formula for volume is 1/3 pi r squared h. A little bit like our pyramid, right? 1/3 times the area of the base times the height. Yep, it is. Volume of a sphere, 4/3 pi r cubed, where r is the radius of that sphere. Yeah, three-dimensional objects. They're kind of fun. Especially now that we have 3D printers, we need to know how much material it takes volume-wise, right? How much material does it take to create these things? Okay, example 6, applying volume formula. So we have an ice cream cone. This is we're going to talk about surface area after this. So we have an ice cream cone that's 5 inches deep. Notice they've got the 5 inches deep right there. So here's the cone part of it, a right circular cone. 5 inches deep, has a radius of 1 inch. And at the top of that, we've put a scoop of ice cream that also has a radius of 1 inch. We want to know if the ice cream melts in the cone, into the cone. If we let it melt and it goes down into the cone, will it overflow? So we need to compare the volumes. Is the volume of the cone going to be enough to hold the volume of the sphere? Okay, if there's more volume in the sphere than there is in the cone, it will overflow. So here we go. We're going to calculate the volume of the cone. We're going to do 1/3 times pi times the square of the radius. The radius is 1, so that's 1 squared, which is still 1, times the height, which is 5. Let's see what we've got. So we've got 1 squared, which is 1, times 5 is 5. We've got 5 pi. We're going to divide by 3. Let's see what we get for our volume of our cone. Volume of the cone is approximately, I'm going to grab my calculator. I'm going to do 5 times pi. And I'm going to divide by 3. And I'm going to get 5.24 cubic inches. For the sphere, our radius is 1. So we do 4/3 times pi times 1 cubed. That's 4/3 times pi, or 4 pi over 3. Either way you want to do it. Doesn't really matter. If you want to do it this way, you can. It's 4/3 times pi, or 4 pi over 3. And that's going to be, let's see what that is. Let's grab the calculator, get us a volume. So here we go. I'm going to clear off some stuff. So I'm going to do 4 divided by 3. If you're not quite sure, then make it do this, and then multiply by the pi. 4/3 times pi. Use those parentheses. I get 4.19 cubic inches. Yes. Or should I say no? Will it overflow? No, it will not overflow. So there's no overflow. That cone melts, or if that ice cream melts and goes down into the cone, it will not overflow because there's enough space in the cone to hold that 4.19 inches cubed. So no overflow. All right, let's talk surface area, which is the last subject here. So example 7, finding the surface area of a solid. The length is 8 yards, the width is 5 yards, the height, where's my formulas? I skipped a page. That's why it looked funny. Surface area, it's the area of all the faces of our three-dimensional object, or in this case, it's the area of the top plus the area of the bottom, which are both pi r squared, so 2 pi r squared, plus the area of the around here. Okay, which if I cut this up through here, if I just cut it and fold it out, it would be a rectangle, and it would have a dimension like this and a 2 pi r, because the distance around that circumference is 2 pi r. So that's kind of where it comes from. These are the common formulas that we use. Notice this one over here, because we have 6 square faces, right? And they're all s squared. We have surface area of 6s squared. On this one, we have 3 different sizes of rectangles. We have 2 that are L by H. There's them. We have 2 that are W by H. There's them. And we have 2 that are L by W. The bottom one, L by W, and the top one. Okay, so those are some formulas we need to use. And then example 7, it's already worked out. So I'm just going to let you read through that one. We literally just look at the length, the width, and the height, plug numbers into the formula, do the calculation, come up with an answer. And that is the end of our video.